Okay, so we're looking at type of integration method where using change of variable by substitution method to integrate expressions. This is the first video. Sometimes this is referred to integration by substitution, where the derivative is present in the integrand. Integrand is the thing being integrated. So we're looking at integration of expressions that are in this form, so f of g of x, so that's a composite function, times by the derivative of the inner function. Okay, so it's f of g of x times g dash of x. Okay, so quickly, if you just pause the video and see as some preliminary work if you can calculate those, notice how it does say derivative, and unpause the video and see how you go. So you would have used the chain rule on each of these. So just remember the chain rule in differential form looks like that. dy dx is dy du dx, where u is a substitution for the inner function. And we use the chain rule with composite functions as we've got there. In function notation, the same thing would be written as f dash of g of x. So that's the derivative of the composite function involving g of x. Now the du dx part is probably easier to see. So the du dx is the derivative of the inner function. So the inner function is g of x, so that would be g dash of x. And the derivative of the y, which is the dependent variable in regards to the substituted variable, which would be like that. So the first one comes out like that. So you can see the form, we've got the inner function raised to some power, that's a function of a function, and we've got the derivative of the inner function. Of course, it's also been multiplied by something, so the derivative of the inner function is 2x, and that's been multiplied by the 4. So for the next one, we've got 2x as the inner derivative, and we've got 4 outside of x squared plus 3x down to the power 3. Oh, hold on, it's 2x plus 3, so 2x plus 3, and we could tidy that up by bringing the 4 out the front, if we like. Like that there. The last one there, we've got, remember that sine cubed x is sine x, all cubed, and we can then proceed. We've got 3 can be brought to the front, which is based on that one there, and the derivative of sine is cos x, and we've got sine x all squared for sine x there, or in other words, we've got that there. So I wonder if we can see, and this is rough, I guess, like we've found the derivative of the function of a function, and we get the derivative of the inner function times a function of the function. Now, what's misleading about that? It might not be the same function. Okay, but we've got, if we look at the last one and work up, we've got the derivative of the inner function there. Now it's not necessarily second. Here it's first. Okay, and we've got a function of the inner function where the inner function is sine x. Okay, and likewise we can see the form for the other ones there. So what we're trying to do is work on an integral of something that's in that form to see if we can get something like this. Can we do it? This is not a rule per se, but can it be reversed? Can we integrate things like this? Well, given that, for this first one here, given that the derivative of x squared plus 1 all to the power 4 is 4 times 2x using the chain rule times x squared plus 1 cubed, which is 8x outside of x squared plus 1 all cubed, which is here. So if we integrate that, we should get back to this. Let's have a look. What about this one here? Well, that one, if we integrate that, that's 1/8 of what we had. So what's a more methodical way of doing this? Because this is very guess and check, isn't it? Well, one thing we can do is make a substitution. So we often say let u equal g of x, something like that. So let's see how that might work in something like this. So we have something in that form that we're talking about. We have a function of a function. So we have somewhere there f of g of x. And that might be this part here, times g dash of x. Well, that would be that part there where g dash of x is that inner, sorry, not g dash of x, g of x. G of x, the inner function, is 2x squared plus 1. Now we said let u equal g of x. Well, g of x is 2x squared plus 1, so let u equal g of x, which is basically let u equal 2x squared plus 1. Okay, now du dx, because remember we've got a g dash of x here, so the derivative, du dx, the derivative with regard to x, would be 4x. Now at this point, this is what I'd like you to do. For reasons you shall see, thus, separating the differentials, du equals 4x times dx, or 4x dx we say. Now we make the substitution. We have, instead of saying f of g of x, we are saying we have f of u. Now we have the integral of f of u, and we have, if we change the order of the product up here, okay, and if we basically were to put, sorry, I wanted that a different color, we basically were to put those two elements together and move the 2x squared plus 1 to the power 4 to the front, it's still okay. We can do that. It's a product. We have integral of f of u times du. Whoop, back to the other color. Because when we move the 4x dx together, we can replace it with d of u. So, you know, like, not that you'd write this, but what we did mentally with your superpowers is basically put that there, like that, and you can see we have that replaced with du. So we have the integral of f of u du. Now if u equals 2x squared plus 1. F of u is the function of u, which is raising it to the power 4. So we actually have the integral of u to the power 4 with respect to u. And that is easy to do. Is u to the power 5 over 5, or in other words 1/5 u to the 5th plus c. And we can sub back in terms of x again. We have 2x squared plus 1 to the power 5 plus c. So 1/5 2x squared, 1/5 outside of 2x squared plus 1 all to the power 5th plus c. One last example. The integral of sine x times cos to the 4th x dx. Okay, so let's be a bit more direct now. I'm sure you'll be happy to hear that. So let g of x, or in other words, let's say just let u, the inner function, be what? Well, it might help, you may not need this by now, but it might help to consider cos to the 4th x as cos x all to the power 4. We can see the inner function and the function of a function there. So u would be cos x. Du dx, the derivative that we need, is negative sine x. So du equals negative sine x dx. So this step here is usually done mentally. I'll put it in light blue. And that means we can replace that. That will be with negative du, okay? So negative 1 du is sine x dx, okay? And so this here is f of u, which is basically the integral of u to the 4. Now we have negative du there, so I'll put the du down, and the negative 1 we can put there, or the negative 1 can go outside, and we have negative outside of negative 1 times the integral of u to the 4 du, and that is negative 1/5 u to the 5 plus c, and then we sub in back in terms of x again. So remember that the substitution was made, u is cos x, so we say negative 1/5 cos x to the 5th plus c, or even better, and in fact those brackets are not really required, so I am going to lose them, that bracket. Okay, so we have negative 1/5 cos to the 5th x plus c as our answer there, or you could say cos to the 5th x over 5, or negative cos x to the 5th over 5 plus c.